This conference will now be recorded.
Good morning, students. Wait for a few minutes. Students have to be joined. Just recall what we discussed in last class. Right, I'm going to start the class. So before going to today's topic, I just want to recall that what we discussed in last class. I mean, that is what are the formulas we discussed. So that all. Right. What is the units of lambda? What is the units of lambda?
Hedges.
No, wrong answer. So lambda is given by flux linkages and it's equals to n pi. Now we can say that what is the units of lambda?
Weber.
Weber tons. Right? This is the units of lambda. And E is equals to minus n d pi by dt. So how we can got this equation from which law?
Maxwell equation.
E is equals to minus n d pi by dt. How we can got this? From which law?
Lens law.
Right, Lenz's law. Uh, so here lambda is equals to n pi and it is nothing but flux linkages. And what is the units of induced EMF? What is the units of E? What is the units of E? See here, just remember that the induced EMF is nothing but a voltage, electromotive force. It means that when a current is flowing through any coil, there is a drop will be occur. That drop is nothing but a induced EMF. It is under form of voltage. So the units of induced EMF is volts. And what is the relation between magnetic flux density and magnetic field intensity? What is the relation between magnetic flux density and magnetic field intensity? Anybody? What is the relation between magnetic flux density and intensity? What is the relation between B and H?
B equals to B.
Yes. So what is the relation between magnetic flux density and magnetic field intensity? So these are the formulas we derived in the last class. Now I will show you one video and then you will get clarity on that what is mean by electromagnetic induction and how we can get that induced EMF from the magnetic induction, right? So just see this video, all of you. After this video, we will continue this class.
Once upon a time, in 1831,
So the Faraday's law was invented in 1831. So how the Faraday's law was introduced, on what are the reasons he invention that Faraday's law, I will show you, you can see in this video. So how the Faraday's law was introduced.
It was an age of scientific discovery, and the chap known as Michael Faraday was at the heart of it. Here is the man himself. Back then he was a humble bookbinder and a self-taught chemist. But through his knowledge and his experiments, he was gaining the admiration of the whole world. What did Faraday do that was so groundbreaking? He discovered a new law of physics, the law of induction. That is the object of this film. In one of his first public demonstrations, Faraday took a simple ring of iron and wound two pieces of copper wire around it. Nothing so extraordinary about that, thought the gathered audience. But then he added the key ingredient, electricity. When one of the wire coils was connected to a battery, or a voltaic pile as they call it back then, an electric current flowed through it. But here's the funky part. There was also a current in the second coil. Suppose the second coil was connected to a light bulb. For a second, the audience would have seen the bulb flash. The two coils were not connected to each other in any way. They were insulated, so no current flowed in the iron ring. So, how on earth did electricity jump from the first coil to the second coil? It did not jump, it was induced. This was the great revelation of Faraday. Electric current in one piece of wire could induce another current in another wire. But what exactly is induction? Let's go back to the modern age and look closer. It turns out that when electricity flows along a wire, it creates a magnetic field. The lines of this magnetic field curve around the wire in circles like rings around a finger. I'm going to take this loop of wire and stick it inside the magnetic field. The loop contains something called a galvanometer, which is a very sensitive ammeter for measuring tiny currents. Watch what happens. Now insert the loop into this magnetic field. The galvanometer moves. It is detecting a small current. I take the loop out, and the galvanometer moves again. If I just hold the loop still like this, there is no current detected at all. My instrument doesn't move. It's only when I move the wire into or out of the field that I get a response. Faraday saw this too, and he realized that an electric current was induced by a changing magnetic flux. Flux is given by the strength of the magnetic field, multiplied by the area of the loop moving through it. In order to get a current inside the loop, the magnetic flux must change. This only happens when I stick the loop into the field or take it out. When it's completely inside the magnetic field or completely outside it, the flux does not change. This is induction, ladies and gentlemen, the manipulation of electricity through a changing magnetic flux. Today we call it Faraday's law. The one thing Faraday didn't do was to write down his law as a mathematical way. I know have some funny looks from physicists who were very keen on their maths. Today we have an equation which looks like this. It is written in terms of induced Emf, or voltage, because whenever there is a current in a piece of wire, there is also a voltage. The voltage across my wire is equal to the change in magnetic flux through it, divided by the time the change happens. So I can make a big voltage by making the loop bigger, which would increase the magnetic flux. Or I can move it in and out of the field very fast, so the time is less. Faraday knew this, and we should be very grateful for what he discovered. This is the exact same principle that allows electric generators to work. For instance, in a hydroelectric dam, there are turbines. In a turbine, there is a large magnet that spins whenever water flows through the dam. The magnet is inside a stationary coil of wire, and as it spins, there is a changing magnetic flux. Therefore, electricity is induced in the wire, and it travels out from the dam to power your home and ultimately charge up your iPhone.
So this is the way of EMF will be induced in the coil, right? So here they mentioned one equation, that is pi is equals to BA. What is B and A here? P is equals to pi is equals to BA, and what is the indication of B and A? Anybody can say that? If pi is equals to BA, what is meant by B and what is meant by A?
B magnetic flux density, sir.
What about A? Area of cross section of coil, right? See here, if the area of the coil will be increased, the flux will be increased more. So it means that the flux is directly proportional to the area. If the area will be more, there is a chances to get more flux. So that is the relation given by pi is equals to magnetic flux density with respect to the cross sectional area. Okay, now so this is what we discussed in yesterday's class. That is different formulas with respect to the induced EMF. Now this induced EMF is seen in the generators and transformers. In present scenario, most of the electrical devices, that is up to 75% of electrical devices, was run by the AC supply. Now today's class we are going to discuss about what is the AC operation on magnetic circuit. So if the device is done by the device is run by the AC supply, what will happen? Let me see. So this is our topic today. We are going to discuss, that is AC operation of magnetic circuit. Now if you are applying the supply by AC, what will happen? So AC means alternating current. The parameters done by produced by the AC supply is always sinusoidal waveform. Why? Because the AC supply in sinusoidal waveform, due to this AC supply, the current is also sinusoidal. The current, due to the current, the flux. So every parameter is in the form of sinusoidal waveform. But in the case of DC, there is a straight line. That is, there is no deviation in the waveform. So what is the frequency of DC supply? What is the frequency of DC supply? Right. Why? Because there is no frequency for DC supply. I will show you how it will be. Why it is. See here, if you are considering the sinusoidal waveform, right? If you consider sinusoidal waveform, it should be like this. Similarly, if you consider the DC supply, it is like this. So this is DC and it is AC. Now, what is the relation between frequency and time? What is the relation between frequency and time?
Inversely proportional to time, sir.
F is inversely proportional to the time. Right? Now, when compared to these two waveforms, where the time was changing with respect to the parameter AC supply, right? So starting it should be 0 and it is goes to maximum, again it's 0, again it's so based on the time period it is keep on to changing. So where the parameter is changing with respect to the time, there is availability of frequency, but here it is a constant. It should not depend on the time, so it is keep on going to the constant. That's why the DC supply doesn't have the any frequency, because the time constant is time is constant in the DC supply, but we have the frequency in AC supply. Based on the time period, we will get that frequency here. In generally in India, we are getting that 50 Hz frequency for AC supply, but we are not getting the 50 Hz frequency. So it is a plus or minus 5 tolerance. So this is called as tolerance value. So what is the meaning of tolerance? Means if you are considering any value which belongs to the electrical system, the value should not come exactly. Suppose if we are getting the AC supply, right, single phase AC supply for our homes, and its value is 230 volts, but you never get that 230 volts exactly. Why? Because of this reason, the frequency is changing plus or minus 5. Due to this, you will get in between that 222 or 230 volts, but you never get that exact 230 volts because of the reason. And in this condition, so when you are energizing them any device with the AC supply, there is a vital role acting by that element is called as inductance. Due to this inductance, there is a certain parameters was changing. What are the parameters will change? Let me see. Right. So let me see that what will happen if you are energizing them any electrical device by AC supply. I already told you that in present situation, most of the applications like machines and transformers are energized by the AC supply. Why? Because we have the AC supply is more availability than the DC supply. Suppose if you want to get the DC supply, the only way you can get that from the batteries. But that much of batteries there is not available. So it is economical problem, right? So that's why we are using all appliances run by the AC supply. Now, in this condition, so in this AC supply operation, what will happen? So in this condition, in this operation, inductance act as a vital role. Why? Because if you see this, if a circuit consists of a resistance and inductance, if you circuit run by the DC supply, suppose మీరు already electrical circuit చూసింటారు. So electrical circuit consists of both inductance and resistance. If you are using the DC supply, then the inductor is act as a short circuit. If you are using AC supply, the inductor is using as a energy storage. Why? Because what is the purpose of inductor we are using, and what will do the current in from the inductor? Current inductor ఏం చేస్తుంది?
Control చేస్తుంది.
So control చేస్తుంది. But in the case of DC supply, we are getting the constant current. There is no need to controllability. But in the case of AC supply, we are getting that unbalanced current. Unbalanced current అంటే నాన్ సైనూసోయిడల్, సైనూసోయిడల్ కరెంట్ అంటే ఒక టైం మాక్సిమం ఉంటుంది, ఒక టైం జీరో ఉంటుంది, ఒకసారి నెగటివ్ ఉంటుంది, పాజిటివ్ ఉంటుంది. సో డ్యూ టు దిస్ అన్కండిషనల్ కరెంట్ వేవ్ ఫార్మ్, we have to control that. So how we can control means the only device inductor. So that's why in AC operation, inductor is act as a vital role. So inductor is also known as reactor. So inductor ni reactor kuda antaru. Okay na? Just remember this words. Now one more advantage is there. If you are applying that AC supply to any material like copper, aluminum, whatever it may be, this BH relationship is satisfied. ఎందుకంటే నౌ ఇప్పుడు ఏ మెటల్ అయినా కానీ దాని యొక్క బిహేవియర్ అనేది ఎలా చేంజ్ అవుతుందంటే మ్యాగ్నెటిక్ ఫ్లక్స్ డెన్సిటీ అండ్ ఇంటెన్సిటీ పైన డిపెండెంట్ అది. సో దాని ఇంటెన్సిటీ అనేది ఏంటంటే అది ఎంతవరకు కరెంట్ ని క్యాపబుల్ చేయగలుగుతుంది, దట్ ఈస్ కాల్డ్ as ఇంటెన్సిటీ ఆఫ్ ద మెటీరియల్. అండ్ based on the intensity, how much of flux density is generated, that is called as B. But in the case of DC, it is not satisfied the BH relationship satisfy చేయదు. ఎందుకంటే we are getting the constant DC supply. Due to this DC supply, the temperature gradient will be increased. సో టెంపరేచర్ అనేది ఎక్కువ ఇంక్రీజ్ అవుతుంది. సో ఎప్పుడైతే టెంపరేచర్ ఇంక్రీజ్ అవుతుందో ఆ మెటల్ యొక్క పర్ఫార్మెన్స్ అనేది రెడ్యూస్ అవుతుంది. సపోజ్ మనమే ఒక హ్యూమన్ తీసుకోండి, మామూలుగా 30 డిగ్రీ సెంటిగ్రేడ్ వర్క్ చేస్తే ఎలా ఉంటాడు, అదే 45 డిగ్రీ సెంటిగ్రేడ్ చేస్తే ఎలా ఉంటాడు. ఇట్ మీన్స్ దట్ ఇట్స్ ఇన్సెన్సిటివిటీ విల్ బి రెడ్యూస్డ్ బేస్డ్ ఆన్ ద టెంపరేచర్. సో టెంపరేచర్ ఎక్కువ ఉన్నందుకు ఏమవుతుందంటే ఎనర్జీ అనేది లాస్ అవుతుంది. అట్ ద సేమ్ టైం when we are applying the DC supply to the material and its BH relationship is not satisfied because of this reason. Now if you are using the AC supply to any material, its BH relationship is satisfied. This is the reason why we are using the AC supply for electrical devices. Now we'll see that in the experiment point of view how the AC supply will act as. Now see here, I am considering one iron core. So this is called as one iron core, like oka metal iron core, iron metal అనేది. సో ఈ విధంగా ఉంటుంది. Now so I already మీరు వీడియోలో చూసారు, ఒక మ్యాగ్నెట్ కి 2 కాయిల్స్ ఇస్తారు ఈ సైడ్ ఇస్తారు, బట్ ఇట్ ఇస్ నాట్ కాంటాక్ట్. సో యాక్చువల్లీ దీన్ని ఎలక్ట్రికల్ పాయింట్ ఆఫ్ వ్యూ ఏమంటారంటే దీస్ కాయిల్స్ ఆర్ ఎలక్ట్రికల్లీ ఐసోలేటెడ్ అండ్ మ్యాగ్నెటికల్లీ కపుల్డ్. అంటే ఎలక్ట్రికల్ పాయింట్ ఆఫ్ వ్యూ రెండు విడదీసిబడి ఉంటాయి, magnetic point of view రెండు కాంటాక్ట్ ఉంటాయి. It means that these two coils are electrically isolated and magnetically coupled. The same thing happening here. Now I am considering that n number of coils which are wound on the iron core. So it is n number of coils. So these are the n number of coils. So 1, 2, 3, 4 there, right? So these are the coils. Now I am placing these coils on the iron core. Okay, iron metal paina vettunnanu. Now so we are placing that again one winding, and I am connecting load like light, whatever it may be. So let's consider it is a light. Now when we are applying the AC supply, when we are connecting this AC supply to the, so let's consider it is a primary and secondary. So then primary secondary అనుకుందాం. First coil second coil. ఎప్పుడైతే ఫస్ట్ కాయిల్ కి మీరు ఏసీ సప్లై అనేది ఇస్తారో దెన్ ఇట్ టెన్స్ టు ద ఫ్లో ఆఫ్ కరెంట్. డ్యూ టు దిస్ ఫ్లో ఆఫ్ కరెంట్, యాక్చువల్లీ ఈ కరెంట్ ఎలా ఉంటుంది, సైనసాయిడల్ వేవ్ ఫామ్ లో ఉంటుంది, రైట్? డ్యూ టు దిస్ కరెంట్, డ్యూ టు ద ఫ్లో ఆఫ్ కరెంట్, ఎప్పుడైతే ఒక కండక్టర్ ఒక మెటల్ పైన కరెంట్ ఫ్లో అయితే ఏమవుతుంది, ఫ్లక్స్ జనరేట్ అవుతుంది. సో దట్ ఈస్ ఇండికేటెడ్ బై ది డాటర్ లైన్స్. ఇట్ ఈస్ అ ఫ్లక్స్. ఓకేనా? ఈ ఫ్లక్స్ ఏం చేస్తుందంటే ఇట్ ట్రావెల్స్ ఫ్రమ్ హియర్ టు హియర్. డ్యూ టు దిస్ ఫ్లక్స్ again it makes the current flow through it, that is called as I2, that is secondary current. Due to the current, light will be on. ఓకేనా? ఇప్పుడు మనం ఇచ్చే సప్లై అనేది సైనసాయిడల్ వేవ్ ఫామ్ లో ఉంటుంది, వోల్టేజ్ గానీ కరెంట్ గానీ వాట్ ఎవర్ ఇట్ మే బి. డ్యూ టు దిస్ పారామీటర్ ద ఫ్లక్స్ is also in sinusoidal. ఓకేనా? So see here, the coil carries an current, the alternating current I, varying sinusoidally. Thus the flux produced by the exciting current is also sinusoidal. మీరు ఇన్పుట్ అనేది ఏ ఫామ్ లో అయితే ఉంటుందో, సో వీఆర్ గివింగ్ ద ఇన్పుట్ ఇన్ సైనసాయిడల్ వేవ్ ఫామ్, దెన్ వి విల్ గెట్ ద ఫ్లక్స్ ఇన్ అవుట్పుట్ ఇన్ ద సైనసాయిడల్ వేవ్ ఫామ్. సో ఇన్పుట్ అయితే ఏ ఫామ్ లో ఇస్తామో అవుట్పుట్ కూడా అదే ఫామ్ లో ఉంటుంది. నౌ హియర్ ద πm is మెన్షన్ దట్ మాక్సిమం వాల్యూ ఆఫ్ ద కోర్. సో మాక్సిమం వాల్యూ అంటే సపోజ్ మీకు కరెంట్ వల్ల జనరేట్ అయ్యే ఫ్లక్స్ ఈ విధంగా వచ్చింది అనుకోండి సైనసాయిడల్ వేవ్ ఫామ్, అండ్ దిస్ పాయింట్ ఈస్ గివెన్ యాజ్ ఎ πm, దట్ ఈస్ మాక్సిమం ఫ్లక్స్. And the maximum flux is given by let me see what is the maximum flux here, and omega is equals to 2 pi f. What is the omega here? How we can call omega? Omega name antarandi. What is the name of omega? If f is frequency, what is omega?
Angular frequency.
Right, angular frequency. Okay na? So enduku angular frequency ante we have the movement in two ways, one is circular motion and one is angular motion. Okay na? So ఇప్పుడు angular frequency ఎలా అంటాం అంటే, suppose let's take this waveform. At this point it has the 0 degrees. So when it is complete to when it is comes to this point, it makes a 90 degrees and 180 degrees. So based on that, the frequency was changing with respect to the angular. That's why omega is given by that angular frequency, and it's equals to 2 pi f. So 2 pi అంటే ఈ విధంగా ఒక angular frequency ఎలా అంటే 360 degrees frequency అయితే దాన్ని angular frequency అంటారు. What is the units of angular frequency? What is the units of angular frequency? No, it is not Hs. Hs for frequency. The angular frequency units is radians per second. So its units is radians per second. So keep remembering all units. Okay, units బాగా నేర్చుకోండి. మీకు స్ట్రిప్ టెస్ట్ అడుగుతాను, వాట్ ఇస్ ద యూనిట్స్ ఆఫ్ angular frequency, what is the units of flux linkages, like that. Okay na? Now when we are applying that sinusoidal waveform, we are getting that flux in the form of sinusoidal waveform. From this waveform we got that pi m. Now there is that what is the induced EMF will be generated in the coil. Okay na? So just note, just remember these two values, that is pi m and 2 pi m. From this we are going to derive that what is the EMF induced in this here, that is E. See, according to the Faraday's law, we have this equation: E is equals to N into d pi by dt. So don't mention that negative here. So negative is only for assigning that how the current with respect to the flux linkages. Okay na? So negative sign దానికి మాత్రం యూజ్ చేస్తారు. But we in calculation point of view we are not considering that negative sign. And this equation we got from that Faraday's law, that is E is equals to N into d pi by dt. Now here pi అంటే actual గా differentiation ఎప్పుడు యూజ్ చేస్తామండి? What is when we can use the differentiation? When we can use the differentiation? So no problem, you can tell me a wrong answer itself. Okay na? కనీసం మీరు నా ఆన్సర్ తెలుసుకుంటారు కదా, తప్పైనా పర్వాలేదు చెప్పండి. When we can use the differentiation? So you guys have did this number of times in mathematics. Differentiation, integration. What is the purpose of we are doing the differentiation? What is the purpose of differentiation? Please tell me the answer. Then only we can proceed to upcoming and next. Right. So differentiation అనేది ఏ కండిషన్ లో అంటే ఏ సందర్భంలో యూజ్ చేస్తారంటే when we want to obtain the maximum value in a parameter. సో ఏదైనా ఒక వాల్యూలో maximum value కనుక obtain చేయాలనుకుంటే then we go for differentiation. That is the purpose of differentiation we are using in mathematical calculations. Okay na? Now here we are applying the differentiation for the pi. Okay na? ఎప్పుడు మనకు pi maximum ఉంటుంది. So this is the waveform of pi, and at this point we are getting the maximum value of pi. So this is denoted by pi m, and it is in the form of sinusoidal. Then I can write pi is equals to 5 max sin omega t. అంటే pi value అనేది ఇలాంటి కండిషన్ లో maximum value ఉంటుంది. That is the way of that is the purpose of we are using differentiation. Differentiation ని ఎందుకు యూజ్ చేస్తున్నారంటే the only reason is for obtaining the maximum value. Okay na? Now from this equation you can write instead of pi you can substitute pi m sin omega t. Okay na? So let's bring pi m is outside. What is the differentiation of sin omega t? What is the differentiation of sin omega t?
Cos omega t, sir.
Omega into cos omega t. Okay na? Actually d by dx of sin xt ఏమవుతుంటే x into cos xt అంటే ఈ x ముందుకు వస్తుంది, తర్వాత cos వస్తుంది. Similarly if you differentiating that pi m sin omega t, pi m becomes constant and differentiation of sin omega t is omega into cos omega t. From this value I can write, so this term is E is equals to E max cos omega t. So here E max is these three terms, n, omega and pi max. Okay na? Are you clear up to this? Now so what is the RMS value? RMS value is equals to maximum value divided by √2. Okay now, what is the abbreviation of RMS? What is the abbreviation of RMS? Guys, are you hear my voice? Yes, RMS is the root mean square. So why actually on root mean square అనేది మనం ఓన్లీ AC supply యూజ్ చేస్తాం, DC supply యూజ్ చేయలేం. So what is the reason is, so the maximum value, average value, RMS value we can obtain only in AC supply. సో మీకు నా తెలిసి నెట్వర్క్ అనాలిసిస్ వచ్చింటాయి. ఏసీ క్వాంటిటీస్, రూట్ మీన్ స్క్వేర్, యావరేజ్ వాల్యూ, పీక్ వాల్యూ, ఫార్మ్ ఫ్యాక్టర్. ఐ థింక్ యూ గైస్ ఆర్ స్టడీడ్ ఇన్ దట్ నెట్వర్క్ అనాలిసిస్. ఓకేనా? సో here the RMS, so this is the maximum EMF Emax, and if you want to find that RMS value of induced EMF, the formula is maximum value by root 2. So substitute here n omega pi max by root 2. Now so here I am writing pi omega equals to 2 pi f. So if you substitute omega equals to 2 pi f, 2 pi by root 2 into f into n into pi max. So the value of 2 pi by root 2 is 4.44. So this is the equation of induced EMF induced in the primary coil, that is denoted by ERMS equals to 4.44 f. So if it is primary means you can put n1. If it is secondary EMF, we can put n2. So this is the equation of induced EMF in the coil, coil. Okay now. So here pi m is depends on that what is the cross sectional area of that coil and what is the maximum flux density, that is Bm. Okay now. So pi max can be written as Bm into A, maximum flux density and area of cross section. So this is the way of finding that induced EMF in a coil which is surrounded on the iron core. So the same EMF equation you can get in the transformer also. So transformer యొక్క EMF equation కూడా ఇదే విధంగా వస్తుంది. ఓకేనా? Next. Now how the what is the equation which is involved in the Faraday's law? See here, the sign of EMF is induced must be determined. So actually Faraday's law ఏం చెప్పారంటే E is equals to n into d pi by dt అని ఇంట్రడ్యూస్ చేశాడు. But the what is the statement of Lenz's law means we have to suppose to put negative sign here. This is the reason why, because the current flow in the conductor which is opposes the flux linkages. That's why we have to put minus here. But in standard equation we are not considering the negative. So the negative sign is indicated only it is a statement wise. Like so the current in the conductor which will opposes the flow of flux linkages, and this was determined by the Lenz's law. Now when the current and flux are in the same phase, so phase అనేది ఎలా ఉంటుందంటే, suppose if you take that current is same here, so this is in the form of current. Due to this current, the flux will be also generated in this waveform. So it means that these two parameters are in the same phase. Due to this, the flux will be produced instantaneously. ఒకవేళ మీకు ఈ రెండు పారామీటర్స్ ఈ విధంగా ఉన్నాయి అనుకోండి, సో వన్ సైనసాయిడల్ వేవ్ ఫామ్, ఇంకోటి వచ్చేసి నాన్ సైనసాయిడల్ వేవ్ ఫామ్. ఈ విధంగా ఉంటే so the flux should not generate instantaneously. That is the reason the current is always in the phase of flux, then only the flux will be generated within the time. Now the induced EMF in the cosine form. Okay na, ఎప్పుడైతే కరెంట్ ఫ్లక్స్ అనేవి సైనసాయిడల్ వేవ్ ఫామ్ లో ఉంటుందో, then you will get in the induced EMF in cosine form. So this is the cosine form here. So sine form అనేది 0 నుంచి స్టార్ట్ అయితే, cosine form అనేది maximum నుంచి స్టార్ట్ అవుతుంది. అందుకని we obtain that maximum induced EMF. ఓకే, ఈ maximum మనం జనరేట్ చేయగలుగుతాం. And when we when the induced EMF in the cosine term, thus it leads the flux and current. సో ఇప్పుడు మీరు అబ్జర్వ్ చేస్తే ఈ ఈక్వేషన్ కి, ఈ వేవ్ ఫామ్ కి ఇక్కడ 0 నుంచి స్టార్ట్ అయింది. సో దిస్ ఇస్ ద వేవ్ ఫామ్ ఆఫ్ కరెంట్ అండ్ ఫ్లక్స్. డ్యూ టు దిస్ కరెంట్ అండ్ ఫ్లక్స్ ద ఇండ్యూస్డ్ ఈఎంఎఫ్ విల్ బి మాక్సిమం. సో ఇక్కడ మాక్సిమం వాల్యూ అంటే ఈ రెండు కంపేర్ చేస్తే ఇక్కడ ఈఎంఎఫ్ అనేది లీడింగ్ లో ఉంది ఈ కరెంట్ కి ఫ్లక్స్ కి. దట్స్ వై ద cosine terms and this leads the flux and current by this is called as back EMF. So back EMF అనేది ఎప్పుడు అంటామంటే when the induced EMF is leads with the flux and current is called as back EMF, and what will happen means it will oppose the applied voltage. ఎప్పుడైతే back EMF generate అవుతుందో and it will oppose the applied voltage, and when the back EMF will be generated when the EMF will leads the flux and current. Okay now, so this is also one of the most important point. So when the induced EMF is present and this leads that flux and current by this is called as back EMF, and it is opposed to the applied voltage. In this condition the drop will be very small and completely it is negligible for the most electromagnetic devices. So this was the different parameters involving in that induced EMF, that is the AC operation of magnetic circuit. Right, now we'll see that when we apply the AC supply, how the energy will be stored. Okay now, so energy is nothing but power. సో మనకి ఇంతవరకు మనము కరెంట్ గురించి చదివాము, వోల్టేజ్, సో కరెంట్ వోల్టేజ్ గురించి చదివాము. బట్ నౌ ఇన్ దిస్ కాన్సెప్ట్ వీఆర్ గోయింగ్ టు స్టడీ అబౌట్ వాట్ ఇస్ ద పవర్. సో వాట్ ఇస్ ద ఫార్ములా ఫర్ P? P is equals to VI. Power is equals to VI, right? So in this case here V is called as induced EMF and it denoted by small e. Now here E is given by the d lambda by dt. So already we know that lambda equals to n pi antamu. So then formally we can write E is equals to n into d pi by dt. So n pi plus and lambda పెట్టేసాను. So final come the power is stored in the AC operation is given by P is equals to I into d lambda by dt. Now what is the work done will be happening. సో వర్క్ డన్ అంటే ఏంటంటే మన ఏదైనా ఒక పారామీటర్ అనేది ఒక టైం నుంచి ఇంకో టైం కి ఎలా చేంజ్ అయింది. సో ఆ వర్క్ డన్ అనేది దేనిపైన డిపెండ్ అయిందంటే దాని యొక్క పవర్ పైన. సపోజ్ ఒక వ్యక్తి ఉన్నారు అనుకోండి, ఒక వ్యక్తి 100 మీటర్స్ రన్ చేయాలి. సో ఆ 100 మీటర్ రన్ చేయాలంటే ఒక వ్యక్తి వచ్చేసి 10 మినిట్స్ లో చేస్తారు, ఒక వ్యక్తి వచ్చేసి 5 మినిట్స్ లో చేస్తారు. బట్ ఇట్స్ డిపెండ్స్ ఆన్ దట్ ద పర్సన్ పవర్. అలాగే ఇక్కడ కూడా మనం ఎంత వర్క్ డన్ జరిగిందో దట్ ఈస్ ఒమేగా ఎఫ్. So how we can work done, we can calculate the work done of the power means when the power is changes from T1 to T2 అంటే ఒక టైం నుంచి ఇంకో టైం కి ఎంత వరకు చేంజ్ అయిందో కనుక్కోవడానికి దాన్ని వర్క్ డన్ అంటారు. డ్యూ టు దిస్ వర్క్ డన్ we can get that how much of output is getting from the particular device, and this will be changes from T1 to T2. Now substitute in this equation, instead of P you can substitute I into d lambda by dt. So dt will get cancelled and you will get omega f is wf is equal to integral of, so ఇక్కడ మనకు ఓన్లీ d lambda parameter ఉంది కాబట్టి the T1 T2 will get changed to the lambda 1 lambda 2. So this is the work done, that is the energy stored in the form of power in a AC that devices. So omega f is equal to integral of lambda 1 to lambda 1 to lambda 2 into I d omega d lambda. Now so this is the equation is given by the magnetic motive force MMR. So here it is generally it is given by the NI. It means that in number of turns how much of current is flowing, that much of magnetic motive force will be generated, and it is mainly depends on that what is the length of the coil and what is the intensity of the coil. So it is completely given by this relation HCLC is equals to NI. So HC is the magnetic intensity of the coil and LC is the length of the coil. From this we can get that I value. So I is equals to HC into LC divided by N. Now this I value substitute in the previous equation. So previous equation what we have, WF is equals to integral of lambda 1 lambda 2 into I d lambda. Now substitute instead of I this equation HCLC divided by N. Now if you substitute this equation you will get this one. Okay now, but we have the relation in with respect to the flux linkages and flux lambda equals to n pi, and here you can write pi is equals to B into A. So that is the B is flux density and area. But flux అనేది it is always depends on that area and maximum flux density, that is flux density A and B. Okay now pi is equals to BA. Finally lambda is equals to NABC. Okay, so number of turns, ఫ్లక్స్ లింకేజ్ అనేది దేనిపైన డిపెండ్ అంటే ఒక కాయిల్ యొక్క నెంబర్ ఆఫ్ టర్న్స్ పైన డిపెండెంట్ అది, దాని యొక్క ఏరియా పైన డిపెండెంట్ అది, అండ్ దట్ హౌ మచ్ ఆఫ్ ఫ్లక్స్ డెన్సిటీ విల్ బి హ్యాపెనింగ్ ఇన్ దట్ కాయిల్. సో దిస్ త్రీ పారామీటర్స్ ఆర్ ఇన్వాల్వింగ్ ఫర్ ద ఫ్లక్స్ లింకేజెస్. Right. Say after substituting this value, now here the equation I am substituting ఎందుకంటే యాక్చువల్లీ లాంబ్డా ఇస్ ఈక్వల్స్ టు n పై తీసుకున్నాము. సో ఫైనల్ గా n పైన ఏం రాస్తాం అంటే n ఇంటూ b ఇంటూ a. ఇట్ మీన్స్ దట్ the lambda is changing with respect to the flux density. So I am writing that instead of lambda 1 lambda 2 by using b1 and b2. Now in this equation the constant term we can get from here. So n get cancelled, AC and LC ఒక కాయిల్ కి లెంత్ అనేది ఏరియా అనేది చేంజ్ కాదు, ఓకేనా, అది కాన్స్టెంట్ గా ఉంటుంది కాబట్టి then we are bringing this outside of the integration, that is area of the coil and length of the coil. So now we have to integrate this value HC, and omega f per unit value is given by B1 B2 HC dB. So this is the what is the units of work done or energy. So ఇక్కడ J by M cube ఉంది. So what is the meaning of J?
Joules.
Joules
So
by cubic meter.
units of energy, right? And here I am mentioning that J divided by M cubed. M cubed ఎందుకు వచ్చింది? How we can append the M cubed? ఎందుకంటే the volume is always represented that cube terms, ఓకేనా. ఏరియా స్క్వేర్ వాల్యూమ్ తెలుసు కదా, వాల్యూమ్ అనేది క్యూబ్ టర్మ్స్ డినోట్ చేస్తారు. అండ్ హియర్ ది వాల్యూమ్ ఆఫ్ ద కండక్ట్ పర్ యూనిట్, సో పర్ యూనిట్ అంటే డివైడ్ బై వస్తుంది. టోటల్ అంటే మీ చేసి ఏం రాదు, పర్ కాబట్టి ఎం క్యూబ్ వస్తుంది. సో ఎం క్యూబ్ డిపెండ్ దట్ వాల్యూమ్ ఆఫ్ ద కోర్, ఓకేనా. సో దిస్ ఇస్ ద ఎనర్జీ స్టోర్డ్ ఇన్ ద magnetic field, okay. Now omega f per unit volume is given by b1 b2, okay. Now I will show you that how the EMF will be induced in the coil. సో మీకు ఒక వీడియో చూపిస్తాను. ఇప్పుడు ఏమైతే మనం ఇక్కడ డిస్కస్ చేస్తున్నామో ద సేమ్ థింగ్, ఇఫ్ యు సీ దిస్ వీడియో దెన్ యు విల్ గెట్ క్లారిటీ ఆన్ దిస్.
The working principle of transformer.
So why I'm saying that, why I'm showing the transformer principle means what we discussed up to now, the same working principle will be happening in the transformer also. అందుకని మీకు ఈ వీడియో చూపిస్తాను.
Actually, transformer is a machine, but it does not have any moving part. That is why a transformer is referred to as a static machine. A transformer has three main parts, two windings, and a metallic core on which the windings are wound. Windings are in the form of coil made of a good conductor of current. The windings of a transformer play a main role in the machine. The winding coils behave as an inductor. When an alternating current is allowed to flow through any of the windings, there will be an alternating flux produced surrounding the winding. The magnitude of this flux is proportional to the magnitude of the current flowing through the winding. The direction of the flux is according to the direction of current. The direction of the current in the winding can be found out by applying right hand grip rule. This rule states that when we grip our right hand with stretching the thumb along the axis of coil or winding and other four fingers along the direction of current in the coil, then the thumb indicates the direction of produced flux inside the coil along the axis. This flux becomes maximum in magnitude when current reaches its maximum for one half cycle of the alternating current wave. The flux becomes zero when current in the coil crosses zero axis. Again, for next half cycle, the flux becomes maximum but in opposite direction when current reaches to its reverse maxima. In this way, alternating current produces continually varying flux surrounding the winding. The flux lines link the winding itself, and the flux is varying, so there will be self-induced EMF across the winding. This phenomenon is due to Faraday's laws of electromagnetic induction. This induced EMF or voltage, whatever you say, is same in magnitude and opposite in polarity of supply voltage. Supplied alternating voltage causes alternating current in the winding, which produces continually varying flux inside and outside the winding. This continually varying flux produces induced EMF across the winding. So we can say that the supply voltage is caused, and induced voltage in the winding is an effect of this cause. Hence, according to Lenz's law, this induced voltage will be in opposite polarity of supply voltage. Since, according to Lenz's law, effect always opposes cause, this self-induced voltage across the winding does not depend upon the number of turns in the winding, but depends on the supply voltage. But the voltage induced per turn depends on the number of turns in the winding. This is nothing but induced EMF divided by the number of turns in the winding.
Okay, students, what is the video is saying that the EMF will be depends on that number of turns. So we have the different parameters is involving. What is that means? Number of turns, frequency, and flux. These are the three parameters are involving for the induced EMF. Okay, now. So this is the topic we in today's class. Okay, now. So it means that how the AC supply will involving in that for operation of a electrical device. సో ఒక ఎలక్ట్రికల్ డివైస్ అనేది ఏసీ సప్లై ఇచ్చినప్పుడు ఎలా ఆపరేట్ అవుతుంది, హౌ ద ఈఎంఎఫ్ విల్ బి జనరేట్, వాట్ ఆర్ ద పారామీటర్స్ ఆర్ ఇన్వాల్వింగ్. సో వి సీన్ ఇన్ దిస్ టుడేస్ క్లాస్. ఓకేనా. సో నెక్స్ట్ క్లాస్ లో వచ్చేసి ఏం చేస్తాం అంటే వాట్ ఆర్ ద లాసెస్ విల్ బి హ్యాపెనింగ్ వెన్ వీఆర్ అప్లైయింగ్ ద ఏసీ సప్లై టు ద డివైస్. సో దట్ ఈస్ ద టాపిక్ వీఆర్ గోయింగ్ టు డిస్కస్ ఇన్ టుమారో క్లాస్. That is next class. Okay now. So next class I think Monday, right? So in Monday class we will discuss about what are the losses will be happening when we are applying the AC supply to that device. So this is the most important concept. Then the same concept you will get in the transformer unit. So transformer unit lo kuda meer same ide derivation untundi. So how we will get the EMF derivation. Okay now. So just keep remember that. And one more thing, all of you install that Google Classroom app. Okay now, from that you can access all my materials, 2 marks questions, previous question papers, and PPTs what we discussed now, like that. Okay now. So meeku already PPTs kuda send chesanu. So దాంట్లో నుంచి మీరు చూసుకొని ప్రిపేర్ అవ్వండి. Okay now. Do you have any doubts now? Mainly units బాగా నేర్చుకోండి. యూనిట్స్, ఫ్లక్స్ లింకేజ్ యూనిట్స్ ఏంది, ఫ్లక్స్ డెన్సిటీ, యాంగులర్ వెలాసిటీ, యాంగులర్ ఫ్రీక్వెన్సీ యూనిట్స్ ఏంది. ఓకేనా. సో యూనిట్స్ బాగా నేర్చుకోండి. Right. So this is about today's class, that is AC operation on magnetic material. So let me see in next class. Thank you. I'm going to end this class.